Okay, so let's look at number 13 on 7.5 in your workbook. So I've got a quotient here under a radical. So whenever I have a quotient, I can write this as two separate, I can use my quotient rule and write it as two separate quotients. So this would become the square root of 1 c to the 4th d to the 7th over the square root of 128. Sometimes it's more convenient to divide them first and then take the square root, but in this case, I don't want to divide them because there's nothing more that I can reduce. But I'm going to separate them and take the square root here. So now the square root of 1 is 1, so I can take that out of the square root. I can write it out front if I'd like. Then there's two ways I can look at this problem. How many groups, how can I rewrite this as perfect squares? So I want to write my C in a perfect square format. Actually, sorry. How many C squares can I take out? So C squared. And how many D squared can I take out? So we know when we have an exponent to an exponent, we multiply. So I need to have 4 C's. Here I have 2. So how many groups of C squared can I have? 2. So this is going to be C squared squared. And how many groups of D squared can I get out of D to the 7th? I can get out 3. So, and how many D's does that leave me? 1 more, so I'm going to write 1 more D. I can't do anything with it, and I'm just going to write it separate. So here's my numerator. I haven't done anything to it. I've just rewritten it. And 128, I need to think of factors that are perfect squares. 64 is, so 64 times what? 64 times 2. All right, so now let's go ahead and take some radicals. So here, once I take the square root of something, I bring it out front. So the square root of c to the 4th is going to be c squared. Or I have 2 groups of c squared. The square root of, I can bring out 3 d's here. So I've got d cubed. And underneath the radical, I cannot bring that d out. It must stay underneath the radical. So here's the numerator. Lily?
How come we can't have the d cubed in parentheses and the 2?
Why would you not have the d cubed in parentheses and the 2 on the outside? Can someone respond to why we're looking for 2 d's, d squared instead of d cubed? Why do we want d squared? Not d cubed. Go ahead, Tatiana. What is that number called right here? The index is 2. So I'm looking for groups of 2. So my index here is 2. It's squared. So it's not written, but that means 2. And that's that number right there, and that's called your index. If it were 3, we would need groups of 3. That's correct, but it's 2, so we need groups of 2. So now I'm going to do my denominator. Now, we're only taking the principal root here. What was the principal root again? All right, so what's the square root of 64? Everyone. You just told me the principal root. What's a more precise definition of square root of 64? Plus or minus 8. That's different. So give me the definition of the principal root now. Go ahead, Tatiana. It's the positive root. It's the positive root. So when we do these problems that are tucked inside of other problems, we always take the principal root. So the square root of 64 is 8, and I'm left with the square root of 2. Okay, so am I all done now? All good? Beautiful? Oh, why not? I have to rationalize my denominator. So now I have to rationalize my denominator. my denominator has a square root of 2 on the bottom, and we cannot have any roots on the bottom. So this is c squared d cubed square root of d over 8 square root of 2. So what am I going to multiply to get rid of my square root of 2? Say it one more time. Square root of 2. So I'm going to multiply top and bottom by the square root of 2 over the square root of 2. Okay, so how would I write my numerator? What am I going to write my numerator? Someone want to say it for me? No? No one wants to go out on the limb? Okay, well let's go over it. So c squared is being multiplied. There's no other c, so I'm going to just rewrite that. C squared. D cubed, nothing's happening to that, so I'm just going to rewrite that as well. Now here I've got something going on here. And the something I have going on is the square root of d times the square root of 2. When we multiply, as long as the index is the same, the index is the square root, they're both square roots, I just multiply what's underneath the square root together. So that square root of d times square root of 2 becomes what, everyone? Square root of 2d, perfect. And in my denominator here, I have 8 times the square root of 2 times the square root of 2. I put those together. So this becomes c squared d cubed square root of 2d divided by, this is going to be 8 times square root of 4, which is 8 times 2, which is 16. Yes.
So when we calculate the denominator and we multiply the numerator by the square root of 2, we only do it by the other square root, like it doesn't do anything to d or c squared.
So when you multiply
Basically just
this square root of 2 down here,
yeah.
why did we not multiply it by c squared? So think about it, think about that square root of 2. You could think about it like an x, actually, if you wanted to. But this, we treat it a little differently. These are just being multiplied. C squared times d cubed times d squared times square root of 2. So here, when I multiply them, I just put them underneath the same square root. Because they're both being under the square root, I just put 1. And then I multiply those two. So my whole term is still technically being multiplied by square root of 2. It's just tucked inside my function. So instead of writing 2 square roots, I'm writing 1 and putting them together. Still multiplication. Now, how do I know if I did it right? Let's talk about how we can check our answers. So let's go over here. Now this only works for our numbers. We can't check our variables. So let's check and see what my answers are. So I'm going to plug into my calculator here. I'm going to plug in this term, the square root of 1 divided by 128. And I'd like you all to check that as well right now. So get your calculators out and let's do that. So it's a good idea to put numbers in parentheses that you're dividing and negative numbers. Not all calculators do have to do it, but it's a good idea. So I'm going to put 1 over 128 inside parentheses. So this will be... Now when you have these calculators, in the same way that you would arrow over to get out of the exponent key, here you arrow over to get out of, you right click over and that gives you out from underneath the radical. Does everyone have an answer? Who needs help? Take a moment, plug this into. Okay, so now that you've plugged that into your calculator, I'm going to call on you to check your answer. Connor, what'd you get? Okay. Finish, keep going. Dash is divided by, that's right. So the same thing as saying 1 over 128 is 1 divided by 128. Yes, what did you get? Okay, so now I'm going to check my answer, right? What am I going to plug in now to check over here to make sure that I've done it correct? What is my new thing I'm going to plug in? On this side over here. Well, what are my numbers? My numbers are square root of 2 divided by 16. So I'm going to check that over here in the calculator. Square root of 2. Now to get out from underneath the square root, you hit the right arrow key over. And then we're going to divide by 16. And our decimal should be the same. And if it's the same, I know that I've reduced correctly. And I know that I've done my math correctly. So you can always check your answers. You can use the graphing calculators, but the little scientific calculators do this as well.